Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Minimum number of changes to make binary string beautiful. In this problem, we are given 0 index binary string S having an even length, and we have to return minimum number of changes required to make the string S beautiful. A string is said to be beautiful if it is possible to partition it into one or more substrings such that each substring has even length and each substring contains only ones or only zeros. We can change any character in S to 0 or 1. Then in example 1, for the given string, minimum number of changes required to make the string beautiful are 2, because one way can be that we can change this 0 to 1 and this 1 to 0. Then we can create the string like this one and partition it into substrings such that this substring is of even length and contains only ones, and this substring is of even length and contains only zeros. Also, there are multiple ways to make the string beautiful. For example, we can change all ones to 0 in this string, and then we will get the string like 0000, which is beautiful because it contains all the zeros. And in this case also, number of changes we did were 2, and for this string minimum number of changes will be 2, and that will be our answer. Similarly, in example 2, for the given string, minimum number of changes required is 1, because we can either convert this 0 to 1, so we will get a string like 1 1, or we can convert this 1 to 0, so we will get the string with all zeros. In either case, minimum number of changes will be equal to 1. Then in example 3, for the given string, minimum number of changes required is 0, because the string is already beautiful with all zeros in it. Finally, in example 4, minimum number of changes required to make the string beautiful is 1, because we can convert this 1 to 0, for example, and then this string can be broken into following substrings with all ones, all zeros, and again all ones. Now, in terms of solution, a beautiful string is composed of even length substrings with all characters either being 1 or zeros. So to achieve this, we can count the consecutive characters in the string to identify how many changes are required to maintain the uniform substrings of even length. So we can iterate on the string character by character and count the consecutive characters we have seen so far. For example, first character we see is 1, so we increment its count to 1. Then we see 1 again, now the count becomes 2. And then we see 0, so that means the character now changes. So this was the uniform string we can form with all the ones. And now the string can be of even length or odd length. For example, here it is of even length. In this case, we don't have to make any changes because our partition is already of even length and contains same character. In this case, it is all the ones, or if it was 0, then it will contain all the zeros. Let's define the changes counter. We will see the odd length partition case in a bit. Now we will try to form the partition with all zeros. So we see first 0, so the count becomes 1. Then we see 0 again, now count becomes 2. Then we see 0 again, now count becomes 3. Then we see 1, that means change of partition, and previous partition contained all zeros and was of length 3, which is odd. So now we have to make a change and increment the changes counter by 1, because for the string to be beautiful, all the characters in the partition must be same. That we are anyways ensuring with the continuous character count, and the partition or the substring size should also be even. And what change we have to make? We have to convert this 1 to 0, so that the length of this partition now becomes 4, which is of even length. And because we converted this 1 to 0, we will not count it as character 1. So we go to the next character and count the first one. Then we see next one again, and now count becomes 2. And now we are done with the string, and length of this last substring was 2, which is even. So we don't have to make any change. And now we are done with the string, and number of changes for this string was equal to 1, and that will be our answer. So now let's jump into the code part. First, let's define the variables. Changes to keep track of number of changes needed, that is our answer. Current char to hold the current character we are counting. Let's set current character to first character in the string, and count to count the consecutive occurrences of current character. Let's set count equal to 0 initially. Now we can start looping on the string character by character. And if character is equal to current char, then we will just increment the count and continue. But if the character changes, that means change of partition. So we will check if the previous partition length is odd or even. In case count is odd, Then we will increment the changes by 1 and set the count equal to 0 because we will not count this new character because we have just converted it to the previous character. Otherwise, we will set count equal to 1 because previous partition was of even length and now we are starting a new partition. In any case, we will set current character to this new character because we will start counting the continuous occurrences of this character. And finally, we will return changes as our answer. Now let's submit this code. Cool. In terms of time complexity, it will be O of n, where n is the length of the string because we are going through each character only once and counting it. And in terms of space complexity, it will be O of 1 because we are not using any extra space, just some variables here and there. And this was a decent approach, but do we really need to check for larger substrings like this one or this one or this one? And the answer is no, as it is a binary string of even length and we have to form binary substrings of even length with all ones or zeros. We can create any number of partitions. It doesn't matter if we choose a large substrings like this or a smaller substring with just pair of two characters. So if two characters in the pair are same, then we don't have to make any changes. So for example, here it is 1 1, we don't have to make change. Here it is 0 0, we don't have to make any change. Here it is 0 1, this time we have to make a change, so we can increment the change by 1. And finally for this last pair, as both characters are same, we don't have to make any change. So then our logic will be simple. We can just iterate on the string with iterator say I, making two jumps and comparing two adjacent characters in the pair. And if both the characters are same, that means we don't have to increment the changes. But if the characters differ, then we will increment the changes. So now let's jump into the code part. We can keep the changes variable as is for our answer and get rid of other variables. Now instead of iterating on the string character by character, we can use the iterator I up till the length of the string with steps equal to 2. And now we will compare two characters in pair, and if these characters are different, then we will increment the changes by 1. Otherwise we will continue. And finally we will return changes as our answer. Now let's submit this code. Cool. In terms of time complexity, it will still be O of n, and space complexity wise also it will be O of 1. But this time the runtime was faster and code is cleaner and smaller. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.